Let's build LLM model from scratch. So I'm importing all the required packages for text tokenization, sequence padding, and numerical operations. I'm taking only few lines of sentence as my corpus. If we need to build large language model, we can have a different corpus with more size. Here for the demo purpose, I'm using only a few lines. Let's start with the tokenizing the corpus. This is for pre-processing text data to train a text generation model. I'm using Keras tokenizer to convert words into unique numerical integers. Total underscore words represents the vocabulary size. All unique words plus 1. The plus 1 is used to account for a special padding index of 0 when creating the vocabulary. For example, for 500 words, the total vocabulary size becomes 501. If we forget to add plus 1, the model might get confused when encountering 0 values since they would not be in the vocabulary. The embedding layer would also throw an out of bound error if an index of total underscore words is accessed. Then I'm converting sentences into sequences. It tokenizes each sentence into sequence of numbers, creates multiple training examples for each sentence. For example, I love deep learning tokenized into 5, 12, 33, 99. For the same tokenization, generated sequence will be 5, 12, 5, 12, 33, 5, 12, 33, 99. Now, we do the padding sequence to equalize the length by giving the padding equal to pre. Next, preparing input and output, leaving the last letter for the Y and remaining words for the X. For example, let's take the sentence deep learning is amazing, which gives the tokenization of 12, 33, 15, 72, which can be written as input and target as shown. Later, I'm doing one hot encoding for Y in order to have zeros and ones as my targets. Then I'm training the model by converting word indices into dense vector representations, adding an embedding layer into it. Now I'm training a model by defining a sequence layers using TensorFlow Keras. It has total words, dimension, input length. So in general, this text generation model built using TensorFlow Keras sequential API, it uses an LSTM to predict next word in a sequence. So for the first LSTM layer, it has 100 memory units. This allows the LSTM to return a sequence instead of single output needed when stacking multiple LSTM layers. So in the second layer, it has another LSTM with 100 units, does not return sequence because this is a last LSTM. So in the fully connected layer, we have 100 neurons, activation function of ReLU, so that the output layer will have the dense total number of words, predicts the next word from all possible words in the output, and converts output into a probability distribution over all words. Predicts the next word from all possible words in the vocabulary, and activation of softmax for the output layer converts output into a probability distribution over all words. Model.compile. Now let's add the loss function into it and an optimizer. At last metric in order to have the accuracy of it. So the model.fit function initiates the training with 500 epochs. Let's give a sample input and try to generate the output. I'm trying to give hi everyone with it so that let's see whether it predicts the expected results. If you see here, it tried to give me all possible words which it learned from the corpus given, which is very limited. If you try to give something similar or from the model, from the data set that we have, it will give the expected words as in possible words from the model. We can also use a pre-trained tokenizer in order to have a large corpus, but whenever we have a requirement, we can't just have the pre-trained model. We need to have a data set specifically designed for the particular requirements. We can try to build something from scratch. So try out with the sample data that you have, pre-process it well, clean it well, so that we can have a better prediction model. If the use case is general, we can use the pre-trained models. So that's all for today. Thanks for watching.